So we're going to take a look today at adding and subtracting fractions that don't have like denominators. And I'm going to teach you guys how to extend your fraction lines and incorporate multiplication into, well, finding common denominators. So I've got 2 6 plus 3 twelfths, and we can see very easily that we do not have common denominators. But the one thing that I always tell all my students is take a look at the largest denominator and ask yourself, can the smaller of the two denominators become the larger denominator? And if it can, that's great. We don't have to go any further. We can just start the multiplication process. But if 6 can't become a 12 by multiplying it by something, then both denominators have to become bigger. So I have so many students that end up saying a number when they don't understand how to find common denominators, and they say that 2 is going to be the common denominator between 6 and 12. And that can't be the case. It's got to be the largest denominator or bigger. So what we're going to do is I'm going to take my fraction of 2 6, and this is what I mean by extending my fraction line. And that allows me to put some parentheses here to show that we're going to multiply both the numerator and the denominator by something. I'm going to take 3 twelfths, extend the fraction line, and I'm going to multiply both the numerator and the denominator by something there as well. Okay, we want to get the common denominator of 12. And so I have to figure out what can I multiply 6 by in order to make 12. Well, a lot of people will say it's 2, and that means we do the same top and bottom. And so now I have the common denominator here of 12. I then have to say to myself, well, how do I keep 12 as 12? What can I multiply by 12 in order to keep it 12? And that's going to be 1. And so we do the same top and bottom. And I always have my students do that, even though we know that multiplying anything by 1 keeps the number the same, because it's just good practice. If we're going to have a denominator where both of them have to be bigger, we want to keep that idea in practice. And so now what I'm going to do below is I'm going to rewrite my fraction with just the new common denominator, and I'm going to multiply my first numerator, 2 times 2, which gives me 4. I'm going to bring down my plus sign, and I'm going to multiply then 3 times 1, which is 3. And I end up now with an expression as my numerator and just the denominator. So what this does is it makes it so that kids aren't going to make the mistake of, if it was 4 twelfths plus 3 twelfths, they're not going to say it's 7 24ths. And that would be adding the top and the bottom here. And we don't want to do that. That's a mistake or a misconception students have. So just having the expression here of 4 plus 3 helps us get our answer of 7 twelfths. And that's completely reduced because nothing can divide into both 7 and 12. If we wanted to take a look or try it, we could extend this line again, and we could try and say, okay, what can divide into both 7 and 12? Well, there's nothing. So we don't have to worry about that. All right, so here's the second example where we can take our two fractions, once again, and extend our fraction line, so 2/3. And the reason we're going to extend our fraction line is because, again, we don't have common denominators. And so I've got to figure out, well, I look at the largest denominator and I say to myself, can 3 become a 9 if I multiply it by something? And again, it's true, we can multiply 3 times 3 to become 9. So that works, and I'm going to do that top and bottom. 9 times 1 is going to keep it at 9, so now I have my common denominator, which I'm going to place below by itself. I still have to multiply my numerator now by 1 for that second fraction. So I'm going to multiply now 2 times 3, which gives me 6. I'm going to bring down my minus sign into the numerator of my new fraction, and then I'm going to multiply 1 times 1, which gives me 1. And now I can simply subtract 6 minus 1, the expression that is my numerator, and keep my common denominator, so I have 5/9. And again, there's nothing that can divide into 5 and 9, so I don't have to extend my line to try to divide and reduce that fraction at all. So for this one, I've got a negative fraction in front, and then I am subtracting a fraction from that negative fraction. And again, we don't have common denominators, so I've got to rewrite this and extend my fraction lines. So I have negative 5/6, and we're going to subtract 1/4. Now again, we're going to look at the largest denominator, which in this case is 6. Now, can 4 become a 6 if we multiply it by some sort of whole number or integer? And the answer is no. So we need to find a common denominator between 6 and 4. And I usually do some jump counting. If I take my 4 and I jump count 4, and then 8, 12, 16, 20. So kind of getting up there, at least jump counting 5 times. Usually I can find a common denominator, usually. So then I'm going to try it with 6. 6, 12, 18. I can stop right there. I see that both of them can become 12. Okay, so I know that I have my common denominator of 12. I just got to figure out how is 6 going to become 12. Well, we can get 12 by multiplying it by 2. So I have to do that with the numerator and denominator. So there's 12. How does 4 become 12? Well, it'll become 12 if I multiply it by 3. So again, I do it with the numerator and the denominator. And now I just have to make sure that I do the multiplication for the top here. I've got 5 times 2, which is 10. And since we're going to have a negative here, it's going to be negative 10. And then we're going to subtract 1 times 3, which is going to be 3. So subtract 3. And this can be a little bit confusing now, because we have 2 terms, both of them are negative. And if I have 10 negatives and then we bring in 3 more negatives, how many negatives am I going to have for my numerator? I always like to think of it as people. If there's 10 negative people in the room and there's 3 more negative people that come into the room, how many negative people are there altogether? And it's going to be negative 13. Now, we have a denominator of 12. So we have an improper fraction. And if we have 12 being the whole, I always think of Legos. It takes 12 pieces to make whatever Lego car we're going to make. It takes 12 Legos to make our item. We have 13. So we can make one whole negative, and that means there's going to be, if we use 12 of the 13, there's going to be 1 left over. And so we end up with a negative 1 and 1/12, which is our mixed number. So there's 3 solid examples to get you started with fractions that have unlike denominators.